All right, in this video, we're going to be doing area and perimeter number 1. So to start, number 1 reads that the area of the triangle is 48 square units. So remember, the area formula for a triangle is 1/2 base times height. It tells you in this problem that the area is 48, 1/2. The base measurement goes from R all the way to T, so 12 plus 12 is 24. And our goal here is to solve for the height, which is the altitude. So 1/2 of 24 is 12. So 48 equals 12 times height. When I divide both sides by 12, I get 4. So my height measurement is 4. Anytime you have these problems, I would recommend writing down the area formula that you're trying to use, and that will make these problems a whole lot easier, especially since you're using the area formula, so writing it down is just going to make it easier to see. Number 2, in the traploid shown, the perimeter equals 45, BC is 9, and AB is 12. Find the area. So again, we're doing area, so I'm going to write the formula, 1/2 base 1 plus base 2 times height. So to calculate this problem, we know that perimeter means that we add all the sides together. So I'm going to solve that in here. So perimeter would equal base 1 plus base 2 plus 6 plus 9. And we know that the perimeter in this case is 45. So base 1 plus base 2 plus 15. When I subtract 15 to the other side, we get 30. So base 1 plus base 2 actually equals a measurement of 30, which means I actually don't need to solve for what base 1 or base 2 are individually, because in this problem, we're adding them anyway. So I'm going to replace base 1 plus base 2 as 30, because that's what it equals. Our height in this problem is 6, because remember, it's the perpendicular, so we have to use 6. So 1/2 times 30 times 6 is 90, so our area is 90. Number 3, the diameter of the small circle is 10. So from here to here, our diameter equals 10. The diameter of the large circle, and I'm going to draw it just below here. I know that diameters have to go through the center, but just for the sake of kind of visualizing the problem, I want to go ahead and just draw it below. We want to find the area of the shaded region. So the first thing we have to do is find the area of this whole thing, as if the whole entire shape is shaded. So that is the one with the diameter of 14, which means the radius is equal to 7. So pi r squared, pi times 7 squared is 49 pi. Now we want to be removing this inside area. So to show removing, we're going to be subtracting. So for the second circle, the diameter is 10, which means the radius is 5. So pi r squared, pi times 5 squared is 25 pi. So to remove the area of the smaller circle, I'm going to be taking 25 pi, oh, I should put a pi after 49, sorry, and subtracting it from 49. 49 minus 25 is 24, and pi just is brought to the end. So our answer is E, 24 pi. Anytime you're doing the shaded region problems and the shaded region is the larger, you need to make sure you're subtracting areas. Okay, number 4 in the figure below, what is the area of the shaded region? So this is a square, which means all of these lengths are 18. So the area formula for square is length times width. So 18 times 18 is 324. The area formula for circle is pi r squared. So we need to know the radius measurement. The radius is actually half of the 18, which is 9. So pi times 9 squared is 81 pi. We are subtracting the areas because we are removing the circle. So I have to start with 324, and I'm subtracting my circle area, which is 81 pi. We can't combine those together because they're not like terms, so our answer is D. Number 5, the length of the diagonal of a 21 by 28 rectangle is blank. So I'm going to draw a rectangle. It's 28 by 21. and we're trying to calculate the measurement of the diagonal. Well, in this picture, I see a right triangle, so that lets me know I should be using Pythagorean theorem. So 21 squared plus 28 squared equals x squared. 21 plus 28 is 1225 x squared. And when we square root, the square root of 1225 is 35. So our length for our diagonal is 35 units. Remember, right triangles exist within rectangles, so using Pythagorean theorem if you're asked to find a diagonal is going to be your best bet to solve those problems. All right, number 6, same problem as number 4. We're asked to find the area of the shaded region. Again, this is a square. So area of the square is length times width, so length and width are both 14. So 14 times 14 is 196. Area formula for a circle is pi r squared. Again, the radius is half of the side, so the answer is 7. So pi times 7 squared. 7 squared is 49 pi. I'm subtracting the area, so I'm going to subtract the large area first, which is 196. And I'm subtracting the circle because that's what I'm removing. Minus 49 pi, giving us an answer of option A. Number 7, what is the length of the arc AB? So the arc length formula is 2 pi r, area of circumference basically, times the angle measurement over 360, and what that does is it narrows down how much of the circle you want to find the circumference for. So 2 pi times 10, our angle is 45 over 360. So in the calculator, I'm going to only type the numbers in. Go ahead and clear this out. So 2 times 10 times 45 over 360. I get 2.5. So 2.5 pi, and that answer is here. Now, I knew I didn't have to put it into fraction because my answer choices allow decimals. So remember, arc length is like circumference, but with the angle over 360. All right, on the next page, we're going to go ahead and do number 8. The difference between the areas of the two circles is blank. So in this problem, we're finding the difference. Difference means subtract. So basically, I'm finding the area of the first one minus the area of the second one. So pi radius squared, so 8 squared, I get 64 pi. Minus pi times 5 squared. 5 squared is 25. So 64 minus 25 is 39. The pi just gets brought down, so the answer is D. Difference means subtract. Number 9, find the area of the figure below. So to do number 9, you first need to know the length and width of the rectangle. Notice how right here it tells you that this distance is 18. So the distance from here to here is the exact same distance from here to here. So 28 minus 18 is 10. Which means that this length is 5 as well as this length. Together, they add to equal 28. Now, this distance, if brought up to my problem, represents the radius of the circle. Same thing is true over here. So what we end up having is a complete circle, if I put these two pieces together, with a radius of 5. And we still need to find the width of the rectangle. Now, in this problem, we have 2 radii. This distance is 5. Well, here to here is also a radius. And from here to here is also a radius. So that means that this distance is 5 plus 5, which is 10. So to do this problem, 10 times 18, length times width is 180, plus pi times 5 squared. 5 squared is 25 pi. Looking at the answers here, the number usually goes first, so the correct answer is B. 180 is the area of the rectangle, and then 25 pi is the area of the circle. 6 equal squares are placed side by side to form a rectangle. The perimeter of each square is 32. What is the area of the rectangle? Well, perimeter means I add all the sides together. All of the sides on a square are equal. So I take 32 and divide it by 4, which is 8. So that means that all of these measurements are 8 because it's a square. And then it also tells you that all of these rectangles, or all of these squares are equal. So this distance is 8, 8, 8, 8, 8. So if I'm finding the area of the full rectangle, I know the length is 8 and the width is 8 plus 8 plus 8 plus 8 plus 8, which is 48. So to find the area, I do length times width. So 48 times 8 is 384. Option B. Number 11, what is the area of this given figure? Now again, we don't have an area formula to represent the shape, but I am going to break this shape up. So this area is length times width, so 8 times 7 is 56. But I can't count that as my answer because it's only part of the shape. To find this measurement, I know that this is 6 plus whatever this 8 is, so 6 plus 8 is 14. So to find the area of this inside shape, I'm going to do 8 times 14. 8 times 14 is 112. Again, not answer C. Option A is too small. So I have 112 plus 56 for 168 of a combined area. So just break that shape up into shapes that you understand. You could have broken it up into another shape if you wanted to. It's just a little more adding. So whatever kind of is easier for you. 12, the perimeter of a polygon is 72 inches. One of the sides is 12. What is the length of the other 3 sides? So in a parallelogram, the opposite sides are equal. So if this length is 12, so is this one. Also, the top and bottom must also be the same, and if the perimeter equals 72, we have to add all our sides together. So 12 plus 12 is 24, plus x is 2x, and it has to add up to equal 72. So when I subtract 24, 72 minus 24 is 48. When I divide by 2, each side is equal to 24. So the answer is C. Now, I definitely know, just by looking at this problem, that A is out because those numbers aren't the same. I need at least 2 numbers that are equal. 13, we've got a square inside, or a square with a triangle inside, and we want the area of triangle DEC. It tells you that the square has sides 12 by 12. So squares, we know all the sides are equal. Well, to find the area of a triangle, it's 1/2 base times height. So the base of this triangle is 12. This distance represents the base. So my base measurement is 12. The height is represented from the top all the way to the bottom, and it's making 90 degrees with the base. Well, the height is actually 12, because that's how tall it is. So my formula, I'm going to do 1/2 times 12 times 12, which will give me an area of 72. So problem like this, notice how the shaded region is smaller than the big shape. That means you don't actually have to subtract to find the areas. All you have to do is just find the area of the triangle. All right, number 14. This one is a little bit large. It's kind of a large problem. So number 14, it says, in the given diagram, QR measures 11 feet, so Q to R is 11. The radius of the circle is 3. What is the area of the shaded region? So the area formula for the circle, remember, is pi r squared. So pi times 3 squared is 9. So I'm going to be subtracting 9 pi. So I know that these are out because those aren't subtracting 9 pi. To find the area or the length of this measurement, remember that the radius is 3, so the diameter is 6, which is represented by the length of RT. So length times width, 11 times 6 is 66. So 66 minus the area of the circle gives me option C. Okay, number 15. How many units long is the circumference of the circle with a diameter of 8? Well, the circumference formula is pi times diameter. So the diameter is 8. I just write the 8 in front, and the answer is G. That's just using the formula. 16, in the figure below, we've got a semicircle and a rectangle. What is the area of the shape? Well, to find the area of the shape, we need to know the length and width of the rectangle. So we have 3. This distance is 2 plus 4 plus 2, which is 8. So the area of the rectangle is length times width, which is 8 times 3, which is 24. So automatically, F is out. The area of the circle, our radius here is 2 because the diameter is 4. So the area for the circle is pi r squared. So pi times 2 squared is 4 pi. However, I only want half of a circle. It's a semicircle. So I have to divide my area by 2 because I only want half. 4 divided by 2 is 2, so 2 pi. So 24 plus 2 pi is option H. So be very careful when you're dealing with semicircles. Remember, they're actually half of a circle. So I need to be dividing my area in half. Number 17, again, what is the area of the shaded triangle? Same kind of problem. So our area formula is 1/2 base times height. In this distance, this is the base. So my base measurement is 8. Again, the height is from the top all the way to the bottom, making 90. So the height is actually 5. So 1/2 times 8 times 5. Half of 8 is 4. 4 times 5 is 20. Option G. 18, the distance around a circular path is 1,000 meters, which is the most close approximation for the radius. So circumference equals 2 pi r. And I know that it's circumference because it's the distance around a circular path. So I'm going to replace the c with 1,000. My goal here is to solve for r, so I'm going to divide by 2. So 500 equals pi, but instead of pi, we're going to use 3.14. So when you divide both sides by 3.14, leaving us with just the radius, we would get an approximation that's 159.23, which is roughly option D. So again, we're using the circumference formula because that's the distance around the circle. And with the circumference, you want to make sure to write the formula so you can substitute incorrectly. And number 19, adjacent segments in a hexagon below are perpendicular, and 4 segments are each 3 yards long. What is the perimeter of the hexagon? So this is actually a bunch of squares. So 3, 3, this distance is 3, this distance is 3, 3, and 3. So to find the perimeter, you're just adding all of the 3's together. So 3 plus 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 3 is 24. Option C.